Vamos a tener ahora una segunda charla con Koush, ¿vale? Lo conocéis, no hace falta que lo presente de nuevo. Ahora en este caso va a ser una charla un poco más técnica. No va a hablar sobre detalles concretos en HTTP con Android, fallos comunes, cómo optimizar y cómo utilizar las librerías para desarrollar aplicaciones. ¿Vale? Koush.
Thank you. So I already spoke earlier this morning, and unfortunately in the last 4 hours I have not learned Spanish, so I will still be speaking in English. Maybe in another 4 hours we can do another presentation and I'll have that down. So I've been doing Android development for 4 years, and in the past 4 years I've gained a lot of knowledge about the Android, just networking and performant networking in general. And I wanted to share some of the things I've learned during my journey. So quick reintroduction. I'm Koush. I created Clockwork Mod. I co-founded Cyanongen Inc. And I've published a great number of Android apps and a lot of open source libraries. I actually had the chance to talk to someone from that's developing a Chromecast type TV stick, and he told me that he was using my WebSocket library, so I was really happy to hear that. And this is, if you follow me on Google+, you'll know that I post a lot of pictures of my dog. This is my best friend Cooper, so if you follow me, you'll see a lot more of him. My other best friend is Wireshark. It's not actually a shark. It's an application for your computer that you can sniff all network traffic. Wireshark is really handy because I like reverse engineering protocols. I've reverse engineered AirPlay mirroring, so that's basically an H.264 stream that goes over a TCP connection to an Apple TV. I've reverse engineered Roku, and that's mostly HTTP. I reverse engineered Chromecast, and that's like a combination of SSDP and dial and ramp. And I've also implemented an entire HTTP client and server for Android, as well as WebSocket client and server and Socket.io client for Android. So I guess what I'm getting at is I really like protocols and I really like networking, and even though I'm not really that well known for it, it's just something I enjoy doing. And a lot of what I learn translates into the apps I've been building and releasing. So HTTP is very simple at first glance. You send a request over the network and you get a response back and you process it. It's so simple that you can do this entirely in Telnet. I'm assuming most of you here are familiar with Telnet. So I'm going to commit the presentation cardinal sin and actually try to do a demo live. We'll see how this goes. It might fail miserably. So let me get the font bigger here. So if I telnet to google.com, port 80, I can just type get/http 1.1 host google.com, press enter twice, and Google will respond with the headers, which is, oh, this has been redirected, this is what you were looking for, the content type, the date, and all sorts of other good stuff. So HTTP, at first glance, is a very, very simple protocol. But it has a lot of features which allow you to do things that really benefit the performance of your app, which I'll get into. So I already showed this. This was my backup slide in case my demo failed. So Android has so how many people here are Android developers, actually? Okay, good. So I'm not going to be completely just talking for no reason, and people are interested, hopefully. So Android has 2 HTTP implementations. There's a HTTP client that's not recommended after Gingerbread. And then there's HTTP Url-Connection, which is buggy before Gingerbread. So you have this weird scenario where, depending on what platform you're on, you have to use one or the other. So generally, you have to use a library that switches for you, right, and provides some sort of abstraction layer. So what are you guys using right now? If you're using HTTP client, raise your hand. Okay. So what about HTTP URL connection? Okay. Anyone using a higher level library? Okay, that's good. So HTTP client, which is not recommended by Google anymore going forward, It's actually a really good it's a really good library. It's based off of it comes from Apache, and it's really simple to use, really straightforward. So you have a client, you create the client, and then you create a request, and then you execute the request and get a response back. And then with that response, you can parse an input stream and get some data and some JSON or string or however you want to read it. HTTP URL connection is the most bizarre API I've ever seen. So you start with this URL object, which makes sense. Like you parse a URL, and then you take a URL, and then you open a connection on it. And this makes no sense. That's like you take this thing that's supposed to be a representation of a resource, and then suddenly you start doing really heavy things with it. It's like if you have a phone number class, and then the phone number class has like a dial method, and it like calls someone, right? Like it doesn't make any sense. So like that. This is my face when I first saw this. I was like, what is going on here? But after you get beyond the weirdness of HTTP URL connection, it's very straightforward again. You have an input stream that you can parse and do stuff with. So these two classes on Android out of the box are a little clunky and not really optimized for where the web has gone in the last like 10 years. They don't follow redirects automatically. gzip is not enabled on HTTP client. I think it might be there on HTTP URL connection. Neither of them do any sort of caching out of the box. So if you execute the same request twice, you're making 2 network requests. This is very bad. And since these are raw libraries, you have to be very conscious of how you invoke them. So if you're invoking from the main thread, you're doing something very wrong, and your user is going to see an activity not responding. At the same time, if you go into the background thread and then you start trying to modify the UI, you're going to see a forced close, right? This is a common Android problem. Furthermore, none of these have cookie support. Neither of these support IP-based load balancing. Neither of these support pipelining, and none of them resume large file downloads. And I'll talk about IP-based load balancing a bit later. Let me see, maybe I talk about it now. Okay, I'll talk about it now. So IP-based load balancing, I'll do another demo. So the DNS system, it supports multiple IPs per host. So if I do an NS lookup google.com, you'll see that Google actually resolves to like 10 IPs here. And this is neat because if you have a cluster of servers and one of these goes down, if you have a really smart HTTP client, you can actually have it fall over to multiple IPs, and the user of the app won't know that your server is down. But this HTTP clients on Android don't support this out of the box. They will try the first one, they will fail, and then the user fails altogether. So you can write better clients that automatically fail over with IP-based load balancing. So HTTP, like I said before, simple at first glance. You have a request, you create it, open a connection, handle a response. Then you start adding on more things. You have a request and you want to redirect. Redirect, create another request, open a connection, handle a response. And to do that in Android, you have to remember to set this thing every time with that URL, every time you call open connection. You have to remember to set that, otherwise your redirects aren't followed. So let's add in caching. And I'm illustrating all this because I've written HTTP clients, and I kind of want you to feel the pain that I went through like doing all this. So you add in caching, you create the request, you check the cache. If it's a cache hit, you can go straight and just handle the response from disk. Simple caching. So caching works by the server saying, when it sends you back a response, it says this, you could cache this response for X amount of time. In this case, it's saying cache control max age 300, which means the maximum age of anything that you keep in the cache for this can only be 300 seconds, so 5 minutes. After that, if your entry in your cache is older than that, you have to come back to the server and say, give me something new. So caching is very powerful in that not only does it benefit your client, it benefits you. So one of my apps that I wrote, Desk SMS, I was paying $70 a day on Google App Engine, and Google App Engine is a fantastic platform. It's very expensive if you do it wrong, but very cheap if you do it right. So you should do it right. I wrote it, the first iteration I wrote, I was paying $70 a day to run this service. And then I was like, oh man, I can't, I can't skip lunch anymore. I can't afford this, right? So I iterated and I optimized the caching, and I got it down to $10 a day by doing all the caching correctly. And this was a combination of the server not processing dynamic requests, and also the clients being able to hit their own local cache more often. So to enable caching on Android, this is really gross. On Android for HTTP URL connection, after 2.3, they have caching available. And to enable it, you actually have to do this weird thing with reflection, where you access these hidden methods and classes and enable it. It's actually really sad, but it works. And that's the recommended way to do it. So here you can you set up a 10 meg size cache, you choose a directory, and then you call via reflection how to set this cache up. So beyond caching, there's also conditional caching. So conditional caching, I could see like some of you are like, what is that, right? Like you got the Jackie Chan look on your face. Conditional caching is really cool concept. So conditional caching, say I go to the server and say, hey, give me your web page. The server says, okay, here's your result, here's your web page, and here's the version of the web page. They call the version the E tag. And then say later I come back to the server and say, this can be 3 days later, 4 days later, not just like the simple 5-minute case. I come back and say, hey server, give me the same web page. And the server, and then I also include, say, if none match, which means here's the version I had before. This is the hash essentially. If it doesn't match this, give me something new. And the server will respond back either with the full result, or it may say 304 not modified, which means, oh, it's good, nothing has changed. I'm not going to send you anything, so you can just use the cache version that you had from before. And this is conditional caching, and it's a better version of just using the cache control, because with cache control, you could potentially make a request or you can potentially get a cache hit and actually be out of date with the server. This way, you don't ever have a cache hit, a false positive. Oh boy, so connection pooling. Connection pooling is when you're making multiple web requests to a server, you can actually, after you're finished with, say I call google.com and I say, give me a web page. After I'm finished with that connection and that request, that socket for Google goes back into a connection pool, and I say, okay, google.com, give me Koush's profile on Google+. I can reuse that socket. And I'll go into more detail later why that's really powerful. So I was going to talk more about gzip, deflate, and all these other things, but like the diagram just started getting really complicated, and this was my face at like 2 a.m. when I was making these slides. I was like, I can't keep up with this. So why should you care about all this? On mobile, this results in a better user experience in many different ways. So there's responsiveness. Every time I load a web page, if I hit it in the cache, instead of having a 500 millisecond to a 1 second delay with like 3G or 4G, it's instant because it comes straight from cache. And this also affects battery life. If I'm not going out to the network, and that's the absolute most intensive thing you can do for the battery, you're saving that battery. And at the same time, you're saving your users money because you're not hitting their data. Like I'm paying, I think, it was like $20 a meg or something it's for my pay-as-you-go sim right here. So apps that properly utilize caching are really helpful for me. And when you have a slow or lossy network, it basically makes, like a mobile network, it makes everything absolutely worse. Your mobile connection is guaranteed to drop like all the time. So these slow lossy networks, since the connection drops, you might have gotten maybe part of the response. What it's going to end up having to do is go back to the server and ask for the full response again. So it's a compounding effect with these types of networks. So I briefly mentioned mobile networks have a 500 millisecond RTT. RTT is round trip time or ping. And 500 milliseconds is enough of a perceptible delay that every time you see that, that's going to be a negative user experience. You want to get this down to as low as possible. So a cache hit, basically 0 millisecond, is the ideal way to fix this. Like cache as much as you can, and you'll have the snappiest responses that you can get. The other way to bring down your response time is to use gzip and deflate. That also addresses the bandwidth or the data consumption issues. So most apps are probably sending like text or HTML or JSON or something back. By enabling gzip deflate, which in Android is not enabled out of the box, I don't think, you get around 600% compression. So if you have, you wrote a Twitter app that has that downloads the Twitter feed, that's maybe 128K of just JSON, which is all text. You'll get that down to 12K. Or 20, sorry, my math up here is bad. So naive HTTP 1.0. I talked a bit about connection pooling, and I'm going to revisit that now. So basic HTTP 1.0, you open a connection, you write your request, so you tell the server what page you want, and you'll get a response back, and then you close the TCP connection. And this is how the very first implementation of HTTP worked, and it was written, when they were just going for a very simple implementation. But as networks evolved and we started using the internet more and mobile came along, this became very, very inefficient. And this is because of this thing called Tcp Slow Start. So TCP is a persistent connection between two computers. And what it does, Slow Start, what TCP does is determine network congestion by checking to see if the acknowledgments from the other end are received every time you send data. So if I send data to Google, Google will send back an acknowledgement and say, okay, I got that data. And then it starts out very slow. It starts out very, very slow. And then the longer I send data, the faster and faster it allows the connection to become. And you can see here, if I have a low ping, it starts out, the throughput starts out very, very slow, and then it ramps up. But the longer my ping is, the longer it takes to ramp up and find what its full potential of the network is. And then mobile, which isn't even on this chart with 500 milliseconds, is, it has the worst ramp up of all. So basically, what I'm getting at is this is something that needs to be addressed in mobile. How do you fix this? And connection pooling was one of the things I talked about. By reusing a single TCP connection, the first time you use the connection, it's going to be very slow. But the second time you come and reuse that connection, it'll be very fast. It'll already be warmed up, so to speak. So it amortizes the cost of setting up a TCP connection every time you reuse it. So a couple fixes for TCP to make it work right with HTTP, which is very single connection based, session based rather. You can use the connection keep alive, which is that says to keep the connection alive between requests. You can use keep alive in HTTP pipelining, and I'll talk about pipelining later. Or you can use Speedy, which is Google's protocol for HTTP that they started rolling out on all their servers in Chrome. So keep alive, that's also connection pooling. When a response is completed, the socket gets put back into the connection pool to be reused. That was introduced and is now the default in HTTP 1.1. So the simple example here, I get the contents of example.com, and then later I get example.com again, except another page. It will end up reusing that connection for me if keep alive is implemented. But keep alive is broken on Froyo or before Gingerbread or something like that. So you have to be careful when using it, that if you're running on a certain version of Android, you need to disable it. Pipelining is very similar to keep alive, but it's a more aggressive version. It's where you send, say I know I'm going to call the server and request like 4 or 5 pictures in a row. I will request all of them up front. Before I even wait for the server to respond, I just say, okay, give me this, 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 and this. And then the server will then respond back with all 3 of those in a row, basically decoupling the need to wait for a response. And this is a lot faster than not pipelining, in that there is the process is no longer synchronous. You'll get a significant improvement using pipelining. But the problem with pipelining is that if the server fails for any reason between your first and your last request, all those requests that were sitting in the queue are then just lost. So you have to be careful when you use it and make sure your server is rock solid. And then finally, there is Speedy. And Speedy is an awesome protocol by Google. It uses one TCP connection. It's built on top of SSL, so Speedy is always encrypted. And it interleaves multiple connections into one, and each connection has its own life cycle. So if one connection dies, that doesn't mean the entire connection, the entire Speedy session comes down. It can continue. And it sits on top of SSL, as I mentioned, and it's negotiated through Next Protocol Negotiation, NPN. Great protocol. It's created by Google, and it's actually been proposed to IETF to become HTTP 2.0. It's funny. I think Microsoft had their own proposal as well, which was shot down pretty quick, from what I understand. And Facebook is actually behind Speedy as well. So the great thing about Speedy is that they solve the go-to-market problem, which is whenever you introduce a new protocol, you have to wait for everyone else to implement it. Whatever that protocol may be. And it may take years and years and years for it to become implemented. But Google doesn't have that problem. Google serves half the internet traffic, and at the same time they also serve, they also ship 50% of all browsers in the world. So they just implemented it in their servers, they implemented it in their browsers, and boom, Speedy's already being used everywhere. Unfortunately, there's no support in the Android SDK for Speedy, so you're going to have to download another library to use it. So what I'm getting at here is HTTP is not simple. It's not as simple as you think it is, and there's a lot of options, there's a lot of knobs and buttons, and you need to use them to really tune your app. And there's higher level libraries that will do this intelligently and in an easy enough way for you to do it out of the box with very little changes on your part. So you need to use a higher level library. That's Arnold saying do it now. Use a higher level library. So here's a couple. These are really, really popular ones. There's LoopJ Android Async HTTP that provides an asynchronous API, cookies, multi-part. aQuery is another very popular one. I think LoopJ is the most used one. That's used by Pinterest and a bunch of other apps. And then there's a couple HTTP implementations as well. OKHTTP is by Square, and they're a great crew. They actually took HTTP URL connection from Android, took it out of Android and put it into this library, and then built Speedy on top of it and added caching. So that's a great library. And then there's Android Async, which is what I wrote and what we use in Cyanongen mod fairly extensively on the Inc side. I wrote that project a while ago because I wanted to write a tethering app for Android for my computer. That was, I wanted a way to be able to tether without having to pay the mobile carrier, so I wrote this app to do it. And I initially wrote the app using threads, but what I quickly discovered was your computer generally keeps hundreds and hundreds of network connections open to everywhere. And trying to tunnel those network connections, pipe them through a phone, and the phone is managing each connection with a single thread, the phone would quickly run out of memory or overheat and explode or something like that. So I had to rewrite it using NIO, which is Java's new IO. It's a non-blocking implementation of sockets. So everything is driven by events and selectors, essentially. So whenever data comes in, a callback gets invoked, and then I process the data. And this is fundamentally different from typical IO, where you are sitting in a background thread and you're calling input stream.read and waiting for something and blocking. This is completely different. So I built an asynchronous API on top of that with futures to power it, and that also supports caching. So you have these libraries, and you're using them, but even though you're using them and you think you're doing caching and you think you're doing everything right, Android still makes things harder. So we'll do a quick quiz. Let's look at some code and you can tell me what's wrong. So anyone want to volunteer? What's wrong here? Yep. You're doing network I/O on the main thread. That's correct. That's gonna show activity not responding, and your application is probably gonna force close, so the user will close it. So keep network and storage access off the main thread. So let's use threads. Threading is hard. So there's a joke I'm sure most of you have heard. Some people, when confronted with a problem, think, I know, I'll use regular expressions. Now they have two problems, right? Threading is, here's the variation of the joke I've heard is some people, when confronted with a problem, they think, I know, I'll use threads. Not true problems they. Race condition, right? Like, so it's just like there's going to be guaranteed to be a race condition of some sort. So on Android, you're doing this hokey pokey. I'm sorry if that's an English metaphor. I'm not sure if you heard of it. It's like this dance where you put your foot in it. I'm not going to dance, whatever. So you start on the UI thread. You run your network I/O on a background thread, and then you come back onto the UI thread by posting, and then you process your results. That's easy, right? So another quiz. What's wrong here? This one's a little harder. This is calling back onto the foreground thread, so that's fine. Exactly. Yeah. Exactly. Yeah. So what happened here? What he was saying was, I'm calling read URL and I'm getting data, and that's happening in the background, and then you rotate the phone, or the user presses back, and then you come onto the UI thread and you start modifying UI that no longer exists, and the app force closes. Yep, that's what that generally looks like. So there's a couple ways to prevent this. You can check the activity.isDestroying and ignore the results that you were waiting for, or you can use an async task and manage cancellation. So an async task, and I assume most of you know what that is. You take this async task, and in the onDestroy, if you have an async task still running, you just call cancel, and that prevents it from coming back onto the UI thread after the activity after the data is done. Unfortunately, this is a huge pain to manage because you might have multiple async tasks going on in the background. It's not guaranteed to be just one. You might have multiple. So what you're going to have is like this whole spaghetti thing in your onDestroy where you're canceling everything that might have possibly been happening. And it's not very pretty. So Android's solution to this is loaders. That handles the background loading, and it manages the activity lifecycle. So if you're loading something and the activity destroys or the orientation changes, the loader will no longer report that result back to you. And it also kindly returns results to UI thread if you do need it. So this is what a loader callback looks like. It's pretty gnarly. 3 callbacks, and it's a little clunky to use in that you create a loader and then you have to use the ID to figure out what exactly you're loading. It's not a very pleasant API. So the API works. The loaders are good, but the API is a little clunky. So going back to Square, they're the guys that make the Square Wallet stuff, and they also release a lot of really cool open source projects. They released Picasso, and I saw Picasso, which is this image loading library. Are you guys familiar with that? Yeah, it's a really great library. I really like it. And I was like, man, this is a really, really awesome API. So Picasso provides a fluid API for image loading. Into image views. So what you start with is Picasso.with context, and you're saying, okay, in the context of this activity, I want you to load a URL, which is going to be a bitmap of some sort. Use this as a placeholder, use this as an error, and then when it's done, put this bitmap into an image view. Very, very simple API, and it's amazingly easy to read. I really like it. I was like, well, I want to do this except for all networking. I want to make something that's that easy to use. So everything starts with, and I call this library Ion. And like I said, we're using it extensively in CM. So you start with Ion, you give it a context, which might be an activity or it might be a service. Ion will then manage the lifecycle for you for that context. And you load a URL. And then you say what you want back. You say, I want a string. Ion, give me this URL as a string. And then when Ion is done, it will call back the callback you provided onto the UI thread and also potentially give you back an exception. So it's just a single callback with an exception or result, very similar to JavaScript if you're familiar with the jQuery APIs. That's the pattern they use everywhere in JavaScript. First argument is the exception, second argument is the result. And it's a great pattern, so it's familiar to anyone who does web development. So Ion also supports JSON. So instead of as string, you can set it as JSON object, and you get a different callback, which returns JSON instead. And you can also do a file. And it also supports bitmaps and documents and image views and JSON classes and input streams. And all through this very, very, very consistent API, which is you give it a URL, you ask it, you tell it what you want, and it will give you back in a JavaScript style callback an exception and result. It's a very simple API. So how does that work? You saw the set callback that was called after asString. This is done with Java futures. So Java, I believe 6 and 7 have a future interface, which lets you, it basically says this is a future result from some operation, some long-running operation. But the future that Java provides doesn't actually let you set callbacks. It assumes that when you want to get the data, you call get, and then it will just wait, and it becomes synchronous. So what I added was set callback, which when the future is available, that's what will be invoked for you. And then I added a cancel. So you can cancel if you decide you no longer want the result for whatever reason. You can cancel it, and it will stop the network request and save data. So futures are really easy to get results, and no blocking, like I said, no blocking necessary, and you can cancel the future whenever you want. So back to Ion. The examples I gave earlier were just very simple examples. Most of the time, you also want to add various headers or whatever. So if you need to do a header like authorization, for example, you could call load URL, then set header, and then the header name and the header password. You can also post with Ion. So you call load, and then if you want to set a string, you set the string body and tell it what you want it to post, and it will post it. And this is what's being sent to the server. So you see the post, the content type, and then the data that's being posted. And this also works with URL encoded parameters. So you can set body parameters, and then those will get turned into a single URL post body and send that up to the server. And this is, once again, what's being set. So the API is like a chained API. So every time you're using kind of like a builder. You load something, you build on top of it with posting or headers, and then you say what you want back in return. And everything is basically just shows up in autocomplete. It's very simple to use. In addition to URL encoded, you can also do multipart. Multipart is not supported in Android out of the box. So if you want to send up key values or files or something like that, this is also handled as well with Ion. And like before, just like all the results you can get back JSON documents, you can also send these up to the server. So JSON files, documents, and streams. And it also has transparent usage of all the HTTP features that I was talking about earlier. So caching, compression, connection pooling, HTTP pipelining, cookies, and the IP-based failover. Unfortunately, there is no Speedy, and I'm sorry, I've been working on it. Ion also has support for various UI elements. So if you want to do a very large file download, you can just say progress bar, and here's the progress bar, and it will it'll inflate it out for you as it's downloading. No extra work on your part. You just give it the progress bar instance. And debugging is very important, like when you're tracking down bugs or tracking down performance issues. If you want to enable like logging for a specific request, you do that with the log tag that you provide it and the log level. And in your log, you'll see every single step that was taken in the course of that request. So you can see when the request was made, when the socket connected, when the header is received, when the response started, and then finally when the response was parsed. And there's more on top of that. You can use self-signed certificates, use multiple URIs, proxy servers, and there's a ton of documentation and samples as well. So I encourage you to check it out. So in CM, we're using Ion extensively in this new gallery that I was talking about earlier. Basically, like we're loading like 40 or 50 images all at once, and it handles it without any of the UI jank because it's very conscious of what happens on the UI thread. But yeah, it's used everywhere. It's used by all my apps, used by hundreds of other developers, and tested across millions of devices and users. So yeah, to wrap up, HTTP has a ton of cool features. and a ton of cool options to make your apps better and make them perform better and basically save your battery life and data usage. And you need to use them. So there's a few higher level libraries. Obviously, I'm going to talk about my own, but the other really good ones are Retrofit from Square, OKHTTP and Picasso, and Volley as well from Google, which is very good. Anyways, that's my chat. If you have questions about Ion or Cyanogen mod or Chromecast or anything, I'd be happy to answer.
You told about get methods and post, but do you support other HTTP methods?
Yeah, all the HTTP verbs are supported.
Can you set wherever as a method, although it doesn't work?
Yeah, you can just type in a string for the verb, and it'll let you use it. Any other questions? Cool. Thanks, guys.